otherwise known as the rate of change, using various methods. First and foremost, slope is used and denoted by the letter m. And we have the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1 to find it. Or when we're using a graph, it's going to be the rise, the change in the rise, over the run, which will be the change in the y values over the change in the x values. So if I'm given two ordered pairs, I can find the slope by first labeling x sub 1, y sub 1, x sub 2, y sub 2. Because every ordered pair is always going to be x coordinate, y coordinate. And here we just have two. So we call the first one the first ordered pair, x sub 1, y sub 1. And then we have the second ordered pair, x sub 2, y sub 2. To find slope, I'm going to then write and fill in from the equation. M equals y sub 2 minus y sub 1. So I'll have 7 minus 4, y sub 2 minus y sub 1, over x sub 2, negative 2, minus a negative 3. So on the top, we're going to have 7 in my numerator. 7 minus 4 is 3, over negative 2 minus a negative 3. We'll double negative here. We know will be addition. So negative 2 plus 3, 1. So the slope of these two ordered pairs would be 3, the rate of change. If I graphed these two ordered pairs and sketched a line through them, 3 would represent the steepness of that line. We could also find the rate of change using a table. So same thing, we want to find the change of my y and compare that to the change of the x. So my y is changing by 8 to 7 by going down 1, negative 1, 7 to 6 by going down 1, and then again, going down 1. My x, negative 2 to 0, 2, 0 to 2, 2, and 2 to 4, 2. So all of these rate of changes is negative 1 over 2, because it's the change of the y over the change of the x. And that is for all 3 of these comparisons. So my rate of change here is going to be negative 1/2. One final way we can look at the rate of change, and that is using a graph. So here we have my xy graph. Here's my x-axis and my y-axis. In order to find the rate of change here, we can use the rise over the run. So slope m is the rise. So if I'm going from this point to this point, I got to go down 1, 2. So going down, my rise is negative 2. And the run, which is left to right, is positive 2, because I'm going in the positive direction there. So negative 2 over positive 2. We will always reduce this. So negative 2 over positive 2 is negative 1. So my slope here is negative 1, which does make sense because my graph here is decreasing. And that's a good way to check your answer. Other things with slope. So if I had a graph of a horizontal line, so this is my XY graph here, and if I have a graph of a horizontal line, such as this, my slope will always be 0. So here slope is 0. Think as if you were standing on this line. There is no steepness to this line. The slope, the rate of change, is 0. Whereas if I was looking at a vertical line, and in this case, my vertical line we'll put right here. It is impossible to stand on this vertical line. So here my slope we call undefined. So these are our two special cases when it comes to slope. So if my line is decreasing, I know it's going to have a negative slope. If I had an increasing line, it would be positive. My horizontal lines will always have a slope of 0, and they would be in the form of y equaling the number. And then my vertical lines will always have a slope of undefined, and my equation here would be x equaling a number.